Hello and welcome to Kingfishers Bridge. I'm James Moss and I manage the nature reserve here. Over the last few weeks, myself and other members of the team at Kingfishers Bridge have been busy recording a number of short videos to provide information about the history, the management and the important wildlife that is here at Kingfishers Bridge. We hope that you find them interesting. I'm stood down here on the edge of our 25-acre lake here at Kingfishers Bridge. On a day like today, with all of the young birds that have fledged from this year's breeding season, particularly the large number of lapwing this year, it would seem like the perfect location to start talking about the history of the project and how it first started. The reserve itself is the brainchild of Andrew Green, who had farmed here for many years, many decades before Kingfishers Bridge started. Indeed, where we are now in 1994 was in sugar beet and potato production, and with the help of a conservationist called Roger Beecroft, Andrew Green was able to come up with the plan for the main habitats that you see today, and the physical work to put those in place began in the winter of 1994 and 95. The project was set up in order to create a wide variety of wetland habitats, but with a sanctuarial nature. That is, the habitats themselves should be undisturbed. They're managed, the habitats are set up, but we leave them alone, particularly through breeding season, as much as possible. As well as being sanctuarial, Kingfishers Bridge is also wildlife first. Being a privately owned nature reserve and independent, we rely heavily on private donations. Those donations are used in entirety to provide management for the wetland habitats and wildlife here at Kingfishers Bridge. We do try and provide some amenities and some hides for a lot of our supporters, but we try and prioritise the wildlife first at Kingfishers Bridge. The owner of the site, Andrew Green, built a house here in the 1970s. As a keen ornithologist, he saw the potential for a wildlife reserve like this on the banks of the River Cam, which runs just to the west of us here and forms one of our boundaries. The River Cam itself is a major migration route for a number of wader and duck species inland off the Wash. One of the main reasons for the variety of successful habitats here at Kingfishers Bridge is down to the geology, what's underneath our feet. When you visit the reserve, you might notice there are quite a number of slopes here for a wetland. Now, wetlands don't tend to do very well on a slope, and what we've got going on here is a slope down from the main parking area and visitor centre towards the north, and again from that same high point down to the west underneath the River Cam. What's causing that mound is a 156 million year old coral reef that runs from here, where it disappears under the Cam, through the village of Wicken, round through Burwell and joins onto Newmarket, which used to be an island. Now what that's actually presenting here is up on the high points of the site. We've got lime rock right below thin peat soils, and then that runs down to deep peats over clays on the lower wet meadows of the site. That variety of geology has allowed us to create a number of habitats, from wet meadows, lakes and reed beds, right the way through to mature woodland and wildflower chalk meadows. For specific wetland habitats such as reed beds, you can't really have any kind of slope across an area like that at all. The water depths are so shallow that even a slight slope across an area will leave it completely dry at one end in order to achieve the water levels at the other. So the reed bed is a prime example to show how Kingfishers Bridge was set up and the management principles that govern us here. The reed beds here at Kingfishers Bridge are perhaps one of the best places to explain some of the methods that we use to exploit the natural features that we have here. Our water, crucially important for wetland habitats, comes from our neighbours at Dimmockscote Quarry, a limestone quarry with the same geology as we have here. They have to pump the water out of their workings in order to carry on processing, and they pump that water straight to us. Having run through the limestone, it's very calcareous, very alkaline, and contains huge amounts of calcium for the invertebrates that live in the water here, and that then transfers higher up through the food chain. In order to get over the slope, you'll see I'm standing on a clear bank through the middle of the reed bed. That's formed out of the natural clay that sits here underneath some of the lower lying areas of the site, and it's effectively stepped the reed bed down the slope in much the way as you see rice paddies in Asia. That has split the reed bed up into 5 distinct hydrological compartments, and particularly through the early stages of the project enabled us to play around with water levels and monitor the effects on the wetland habitats within the reed beds themselves. More recently, with the change in livestock grazing and management through the reed beds, they give us a place to put a firm electric fence to segregate animals from each of one of the 5 compartments every year. That seasonal rotation gives us a mix of reed right the way through its stages, from fresh young reed growth all the way through to mature reed. Reed bed itself is a successional habitat. That means that it doesn't stay reed bed for long, but turns into something else. Reed grows so vigorously that it actually causes its own demise, building up a layer of dead stems and drying the wet habitat that it needs to survive. In order to stop this succession, you need rivers to keep flooding and keep scouring away new areas that can be propagated with reed that hasn't been scoured away in that season. Obviously, in East Anglia, we don't allow rivers to flood anymore, certainly not to that destructive level. As flooding rivers is not a natural process that can be returned to Kingfishers Bridge, we've had to find another solution. We've done that with water buffalo. The water buffalo are fenced into one of the 5 compartments each year. Once they're in there, they will graze out all of the green leaves and stems and then move on to the dead woody stems as well. After they finish those off, they will use their horns to start digging up the rhizomes that lie underneath the mud, and in doing so disperse and spread and break up that dead stem litter layer from the last 4 years of reed growth. The clay banks running between each reed bed compartment now serve a new purpose. They allow us to put in firm electric fences each grazing year in order to contain the buffalo into just their one compartment, so that the other reed bed compartments remain undisturbed. In moving through the reed bed, the buffalo will trample deeper channels through the reed bed, joining the water bodies, and that can allow fish to spread up and repopulate any water bodies that have dried out over the course of the summer, meaning there's always a really good fish stock the following spring for our breeding bitterns and rails. This succession of reed, from thin, fine reed stems from a compartment like this, which was grazed late last summer, through to older reed here, where you've got a lot more dead, dense reed clumps in there. That range of reed growth is important for a whole range of different species that may use different ages of reed at different stages in their development. This reed bed is particularly good for bearded tits, sedge warblers, reed warblers. We have bittern trying to breed here every year, in many cases successfully, and marsh harriers. One of our main indicator species for monitoring our management here in the reed beds at the reserve is the reed leopard moth. It's quite a small, indistinct white moth with a long body, but it's incredibly rare in Britain, formerly only occurring at Wicken and Chippenham Fens, but also occurring in large numbers here because of the way that we manage the reed. The reed leopard moth will overwinter as a larvae in the base of the reed stems right on the waterline for a number of seasons, before finally hatching out into the adult moth to go off and breed. Because we don't cut mechanically here at Kingfishers Bridge, using water buffalo instead, the buffalo will graze down to the reed base tussock, but won't destroy the majority of those reed bases, allowing them to propagate year after year with the reed leopard larvae safely inside. At 50 acres, our reed bed here at Kingfishers Bridge is relatively small and isolated, especially when you consider the reed beds of ancient East Anglia that stretched for hundreds of miles. This presents a problem for some of the species that use the reed beds here, particularly with regards to terrestrial predation from animals such as foxes and rats. Now, whilst rats are good swimmers and would be naturally present in the ancient reed beds, foxes are very different and need dry areas in order to nest and rear cubs. Banks like this are entirely artificial, as are the road and rail banks of the drained fens. You wouldn't normally find an animal such as a fox in the ancient landscape of East Anglia. This makes the breeding animals here in the reed beds at Kingfishers Bridge particularly vulnerable when a fox can cross a reed bed like this many times in one night. In order to replicate the scale of the ancient fens of East Anglia, we have a very sophisticated electric fence system. This fence is a combination of normal stock fence and electrified anti-predator fencing, running at close to 8,000 volts. This fence is not predator proof. A fox is able to jump the live wires of the fence, and in some cases we have had foxes within the reed bed at Kingfishers Bridge. But on the whole, foxes will touch the live wires of the fence, get their 8,000 volt electric shock, and decide that it's really not worth tackling this challenge again. In this way, we're able to replicate an ancient predator balance of the old fens by limiting fox and other terrestrial predator incurrence into these reed beds. So whilst a number of the management methods that we use, water pumped from a limestone quarry, grazing with Asian water buffalo, and surrounding it with an 8,000 volt electric fence to replicate flooding rivers and the scale of reed bed around, we're able to replicate a habitat that is very indicative of those ancient fenland landscapes. At the time that the reed bed was set up here at Kingfishers Bridge, the standard practice for setting reed bed was to use plug plants. That's little seedlings planted out by hand on wet mud, and it was coming in at several £1,000s an acre. Andrew Green, being the fen farmer that he was, decided that he didn't want to spend thousands of pounds on his reed bed, and as such he looked at current research into reed propagation and was able to obtain a large amount of seed, which was then vernalised by heating it and then cooling it to replicate a hot summer and a cool winter, and that activated the seed. The following spring, when the wind blew, the seed was scattered into the wind where it drifted onto the water, was blown across onto the shallow mud right on the water level, and it germinated. When the wind blew in the other direction, the process was repeated until reed had spread around all of the water bodies in this area, whereupon it grew. Not everything went as planned, however, and despite fencing these areas of delicate young reed, lots of waterfowl got in there, ate it, chopped the tops off, trampled it. But in fact, that led to all of those little reed stems breaking in half, drifting off again and resetting, and it actually made a thicker, more vibrant reed bed as a result. The owner, Andrew Green, is now very proud of telling everyone how he has 50 acres of reed bed for the grand total of £28.50. It's this process of not necessarily attacking, but just always questioning current conservation practice that allows us to test different techniques and maybe find some new and more efficient methods of doing things.